to write a complete ionic equation. Is everybody listening? We're going to only break up those things that are, ionic and aqueous or acidic and aqueous. Ionic and aqueous or acidic and aqueous. Has to be both. Okay, you got two different categories that you can break up. One category is both ionic and aqueous. The other category is acidic and aqueous. So if it's ionic and solid, we don't break it up because it has to be both at the same time. Yes. Okay. And to repeat for, I don't know how many times it's been, but many, many times, you can tell if your formula is ionic because it'll fit one of two categories. You can tell your formula is ionic because it'll fit one of two categories. If it contains a combination of metal and nonmetal, that's ionic. Okay, that's one category. If it contains a polyatomic ion, that's ionic. That's the other category. If it doesn't meet one of those categories, it's not ionic for this class. Okay?
Mr. Taylor.
Yes.
So it can be ionic and it don't be aqueous?
That's true.
Okay.
It has to be both. It has to be both. All right, so let's look at these formulas then and figure out which ones will break up. Okay? Everybody with me? Okay, Alicia, will this formula right here break up? Yes. Why? Okay, so it contains a polyatomic ion, which makes it ionic, but you've got to have two conditions for it to break up. What's the other condition? Now, we're just talking about this formula right here. It's ionic, but it's got to have two things. Ionic is just one of the things it needs to be to break up. Yeah, aqueous is the other thing it needs to be. Okay? So we will be breaking this one up. All right? I'm going to put a star above it. We're going to break that one up, okay? Got it? Sharon, will this one break up? I'm sorry. Huh?
Do you know her sister?
Do you got a sister?
Sharon and Aaron.
Really?
Okay.
Okay. I don't know why I keep calling her Sharon. Taylor, will this break up? Why? Huh? What do you say? Aqueous. Okay. That's not. It can't just be aqueous.
And ionic.
It has to be both ionic and aqueous or acidic and aqueous. It is ionic because why? Metal and nonmetal, so it's ionic and it's aqueous. Okay, so you break it up. I'll put a star above it. Okay, let's look at this one. Is this one going to break up?
No.
Tylen, is this one going to break up? He says he's shaking his head no. Why?
Because it's not aqueous.
That's right. So it can't break up if it's not aqueous, but it has to break up. It's got to meet two conditions, and one of those conditions it doesn't meet. Now, Amber, this is one of those ionic compounds that doesn't break up because it's not also aqueous. Huh? Yeah, because it's a solid. Okay. Got it, Jasmine. What about this one right here? Is it going to break up or not?
Yeah.
Why? Because it is not an answer. Hmm?
Because it's ionic.
It's got to be two things. It can't just be ionic. It's got to be both ionic and aqueous or both acidic and aqueous. How do you know this? You said it was ionic. How do you know it's ionic? Are you listening for somebody else to answer it so you can answer it out loud? Okay. Well, are you listening for the whole thing when I've been going through this stuff? You need to listen carefully. There's two ways to tell when you have an ionic compound. Do you remember me saying that in this class?
What?
There are two ways to know when you have an ionic compound. Huh? Okay. Do you know how to tell when you have an ionic compound?
Are you asking?
Yes, I'm asking. An ionic compound is one of two kinds of formulas. It will be ionic if it contains a polyatomic ion, and it will also be ionic if it's a metal combined with a nonmetal. Okay, so it can be ionic if it contains a polyatomic ion, or if it's a metal combined with a nonmetal. So does this meet either one of those conditions? Which one does it meet? This formula has more than two atoms. If it has more than two atoms, you go and find, do you have out your test references? If you have more than two elements, you want to go to your common ions list and try and find some part of this formula that's on this common ions list. If some part of this formula is on this common ions list, chances are really, really strong you have an ionic compound, because these are polyatomic anions or ions. That makes it an ionic compound. Okay? So do you see any part of this formula that's somewhere on this common ions list? You don't answer for her, let her look. Nitrate. There is a polyatomic ion, therefore this substance is ionic. That makes sense? Now there are two kinds of ionic compounds. You can tell from the formulas anyway. When you look at the formulas, you can tell it's ionic if it contains a polyatomic ion, so this one is. Or you can tell if it's ionic if it contains a metal combined with a nonmetal. Look at all of these formulas. Do you see any formulas where you have metals combined with nonmetals? All right, there's a polyatomic ion in this one, so that's not a metal-nonmetal combination. This one right here might fit that definition. Magnesium, how do you know magnesium, the first one, is a metal? No. Let her answer. How can you find out if magnesium is a metal or a non-metal? Where would you look? Where in that? Okay, here's the periodic table. You see the stair step? You see that stair step on that big periodic table? Jasmine? Okay. Everything over here on this side, those are nonmetals. Everything over here on this side, those are metals. And if you go back and look in your Unit 2 notes, you were supposed to draw an outline. I gave you an outline of the periodic table. You drew the stair step in and labeled that. Okay? It's in your Unit 2 handout. Okay? So if you go back and look, you'll find that same information in there. So magnesium is right here. So is it a metal or a non-metal? Metal. Chlorine is right here. Is it a metal or non-metal? Non-metal. So is this a metal-non-metal combination? Yes, it is. Because it has a metal on this side and a non-metal over here. So it's a metal-non-metal. That's an ionic compound. How about this right here? Is this going to be ionic? Why? What? Oh, okay. Okay, well, if you're looking for AG, it's right down here. Don't talk to her. Let her think it through, okay? Really. Let her think it through.
So it's the same thing as the other one?
Well, in the sense that it's a metal and non-metal combination, yes. So is it an ionic compound? That's the question. Yes, it is, because it's a metal-non-metal combination. Okay? All right. So if it contains a polyatomic ion, and you find that on the common ions list, or if it's a metal combined with a non-metal, it's ionic. Okay? If it's both ionic and aqueous, it breaks up. But if it's ionic and something else besides aqueous, it doesn't break up. Alright? If it's an acid, I'm just going to write an acid down here. Here's an acid. Okay? If this acid is also aqueous, then to write an ionic equation, we'll break it up. Alright? If, on the other hand, I have an acid that isn't aqueous, it does not break up. Does that make sense? Alright. So now let's go back and try to write a complete ionic equation. Alright? Let's make a complete ionic equation. Yes? Sure. So if you haven't written that equation down, write it down on your paper and let's work through this, okay? Write this down on your paper. Let's work through this. Now when I say breaking them up, we have to break these up into separate charged particles. Okay? So that's the way we're undoing what we did when we made the formulas to start with. Say what? That's NO3 and then parentheses 2 on the outside. Is that what you're asking? Okay.
It's a complete ionic equation.
Well, I want you to write a complete ionic equation to start with, yes.
So where do you start?
Well, this is an ionic compound, is it not? Did we not identify that?
I already know them.
And we're going to break it up. We'll put a star over it. We're going to break it up. Okay? So what we want to do is we want to break it up into separate pieces. The silver and the nitrates need to be in separate pieces. Okay? Because it's aqueous and it's ionic. But when we break those pieces up, they become charged particles.
So that means you're going to have to go to the chart?
You're going to have to, well, there's two different places. You might, for some of them, like this silver, you can go to the periodic table with oxidation numbers. For some of them, like this polyatomic ion, you go to the common ions list. And in some cases, there's more than one oxidation number. You have to figure out which one it is.
So silver is 1+.
Yes, silver is going to be 1+. So manual, what is nitrate's charge going to be?
Ooh, I don't know, dude. Make her find out.
Thank you very much. What is nitrate's charge going to be? It's a 1-. Okay? If the formula up here in the original equation shows this to be aqueous, if the formula up here shows this whole formula to be aqueous, Rob, what physical state do I assign to the resulting ions? Yes, you. If the physical state for the whole compound is aqueous, what physical state do I assign to the resulting ions when I break them up? No, sir. If the original compound is aqueous, then the resulting ions are also aqueous. Okay? Please remember that, okay? Yeah.